How are you, everybody who is watching this video? My name is Olenjolaim single from beautiful country called Tanzania, eastern of the African continent. I'm very happy to welcome you. Whether you are international viewer or a national viewer. It means when I say national viewer, you are Tanzanian or you are an international viewer. I'm very happy to welcome you into this fantastic moment of learning the beauty of higher engineering and the scientific mathematics. I would like firstly to welcome you into our online undergraduate. Okay, so this is the undergraduate. I just forgot some few letters there. Undergraduate. So undergraduate polytechnic. So just you have to understand that here we have some missing letters. Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. Because we are studying mathematics, and one of the main interesting topic in mathematics is called algebra. And in algebra, we have simultaneous equations, which may be either that we are solving two simultaneous equations, or three unknowns, or four unknowns, or five unknowns, but it's the matrices. I would like also to welcome you simultaneously into one of our YouTube channels that's called Online Undergraduate. So these are abbreviations of this word, undergraduate. So it's called the Online Undergrad Poly Institute. These are abbreviations of these two words, Polytechnic Institute. So we have the 10th Poly Institute of Tanzania in square bracket OLENJOLAIM. Remember that my name is Olenjolaim or TAYAI. Simply call me Olenjolai. It's enough. Okay, so before I go into too much details of this lecture 2 of matrices and basic calculus, I would like to remind you the vision that God has revealed in my mind, because the word of God said that if there's no vision, people perish. So if I don't have visions in this online undergraduate polytechnic, that's Online Undergraduate Polytechnic Institute of Tanzania, then I will perish, and even these programs also is going to perish. So I'm not ready to perish. That's why I asked the vision from God, and God has revealed these visions for almost more than 6 years ago, and I've been practicing it day after day. Doesn't mean that I know everything, but I just know small portions of it. So this is the vision that God has revealed, and I would like to declare onto the mind of my students so that we can match together and then to do great things for the rest of our life. This is the vision that God has revealed, that I have an assignment. God has given an assignment to prepare some special group of students through teaching, incubating, mentoring, leadership skills, and even training, okay? On how they can take the classroom instruction in engineering, science, and the mathematics to combine with the knowledge of Word of God, right, in order to solve real life problems. Somebody is asking me that, what does it mean? Myself, I'm a product of classroom instruction, plus I'm also a product of the knowledge from the Word of God. So I combine these two great fields of the world, because when it comes to the word of God, it means that I'm combining invisible and visible word. Where are we living? This planet is called the visible planet. When we are talking about spiritual planets, means that it is invisible, it's powerful, because it's ruling, dominating, and reigning, and governing everything. So that's an assignment that God has given me. So in case you are praying for me, pray that to make sure that to fulfill. And a good example, just to go and read the lifestyle of Joseph in Genesis 41. I will be using a wisdom and kind of different ways of teaching. I will be also teaching you your classroom instruction, and also I will teach you the Word of God, regardless of your denominations and your religions, because the Word of God is for everybody who is ready to receive, keep, believe, and practice it, right? So regardless that whether you're Christians or non-Christians, don't limit yourself that other things in these programs will not be for me. The Word of God is for the mankind life, right? And that Word of God is not from any gods, because we have God and other gods. So that Word of God is from the Bible, right? So that's the vision. So our main objective in this program is not to help students to pass exam. Our main objective in these programs is to help students on solving real life problems. Because remember that the vision is this, that the students who are ready to take the classroom instruction in mathematics, science, engineering, combined with the knowledge of Word of God in order to solve real life problems. I left that part for what? For what purpose? To solve real life problems. Whether it is small scale problem or large scale problems or medium scale problem. For example, myself, I'm solving a national problem, and even this is international problem. So for you, you might be beginning on solving your own problems or your family problems. I'm also solving some other problems. This is the problems that I'm solving through this methodology of teaching differently, and also that changing the mindset of the mankind. So that's the vision. So our main objective to see our continuing students in an undergraduate level solve real life problems, and even they have a strong desire and they challenge themselves every time they are learning something in class. Where am I going to use this knowledge to solve a real life problems that's waiting for me and make God to bring me into this world? Okay, we have some specific objectives. I would like just to remind you quickly. One of the specific objectives in this program is, first of all, to make our students to love higher engineering and scientific mathematics. That's one. And number two, we like also to help them to understand the course or the modules that they are learning in engineering mathematics. That is about the specific objective for the departments of higher engineering and scientific mathematics. And then our third specific objective is we like to see how to help students in order for them to master and pass well the year continuing assessment when they are doing the year courses or the year learning in an undergraduate level. Right? Can I mention the third one? The fourth one, the fourth specific objective in departments of high engineering and scientific mathematics in online undergraduate Polytechnic Institute of Technology is to help our students to graduate successful their undergraduate education and even to pass all the incoming exams, including the test 1, test 2, any kinds of the quiz, any kinds of final exams, so university exam. Well, so let us go now to the business, right? I think that you have a quick review. Let me begin this quick review. In this channel concerning about the basic matrices and the matrices and basic calculus, I recommend you to review a lecture which has been labeled as lecture 00. Okay, that's it. It will be titled General Introductions of Matrices and Basic Calculus. So you will get into too much details concerning about this program. What are we doing? However, that is summarized in a lecture of 1 hour. Not more than, I think it's not more than 1 hour and 20 minutes. I don't remember exactly the amount of time. So it's called the General Introduction of Matrices, okay, and Basic Calculus, right, for undergraduate student. And then, because this is lecture 2, right, also in the same channel, our YouTube channel, you can search it for lecture 1, which is titled as General Introduction, so you can cover these contents before, because you have to link learning, demanding the flow of the information from the fundamental to the higher level. So the general introduction of vector, okay, begins in vector. And then in these general introductions of vector, first of all, I told you that in Tanzania, where my training or my teaching of undergraduate will be taking a focus, however, that these contents will be universal, because mathematics is universal, and engineering mathematics is universal, and scientific mathematics is universal. So these contents will be used worldwide and help even some other international students. But always, even that you're watching videos from MIT, Massachusetts Institute of Technology, or videos of engineering mathematics, maybe from Stanford University or from maybe Oxford University. So they have the focus of the year curriculum. So even myself, my primary focus will be on the curriculums of Tanzania. So I told you that in Tanzania, we have two authorities that are accrediting the institution, the middle and higher institution, middle and higher colleges, and even universities on providing diploma education and also undergraduate education. So one is named TCU and other one is called United. This is Tanzania Commission for Universities and this is National Council for Technical Education. So these basically these modules of or course of matrices and basic calculus, I'm teaching 80 under the TCU. And at the TCU, we have so many engineering colleges and universities. We have so many, okay? We have so many. Just to remind you quickly, first of all, we have the oldest and the number one university that's called the University of Dar es Salaam. And also you have against the largest university in Tanzania that's called the University of Dodoma or UDOM. And also we have again another institution that's called the Zanzibar University. Okay, Zanzibar State. So Zanzibar State University, okay, in Zanzibar, okay, Iceland. And also we have another one called St. Joseph College of Engineering or St. Joseph University of Tanzania, okay, University in Tanzania. Also, so we have so many universities that are providing. We have also African University of Tanzania. So I've mentioned, if just we go quickly there, you just have a reference on these universities that providing. We also have another university called the Kampala International, okay, University in Tanzania. So Kampala International University in Tanzania. So you have so many institutions or so many colleges or universities who are actually that they are learning the modules titled the course called matrices and basic calculus. However, that I'll be using the curriculums of University of Dar es Salaam, right? So at the University of Dar es Salaam, this module is a module course at MT161. Why am I using the curriculums of University of Dar es Salaam? That's a very good question. According to my research, when I've been visiting prospectus of Udsm, prospectus of UDOM, of Zanzibar State University, of Kampala International University in Tanzania, St. Joseph University in Tanzania, also African University of the United African University in Tanzania. Then I noticed that they just took I don't want that to say that I don't know how they discussed the University of Dar es Salaam, but the contents of matrices and basic calculus at the University of Dar es Salaam is the same with the contents of all other engineering institutions. So that's why I said, okay, because this is the oldest, possibly they are the one who have developed the contents and then they negotiated with other institutions. Okay, so that is, so then in this lecture one, again, I presented to you about topics, okay, topics that we are going to learn of matrices and the basic calculus. So hopefully, according to my memory, I present to you 6 topics, right? 6 topics that we are going to cover together. And one is called the Laplace transform, or Laplace transform. Then, in this lecture, I presented again about, because I mentioned some of the universities that can benefit and given students they can learn about these contents. I presented the subtopics, okay? The subtopics or the concept that the subtopics of 40 of vector, because the first chapter is called the vector algebra, right? So the first chapter is called the vector algebra. As I wrote, chapter 1 is called the vector algebra. So what are we going to cover in vector algebra? Again, I began to define the meaning of the word scalar and then the meanings of the word vector. That's not only, but also I discussed about notation of 40, notation of vector. So for you to get into too much details, this lecture or this contents of this lecture 2, lecture 1 of general introductions of vector is still in our official YouTube channel. We didn't remove it yet. You can go through, and I advise you to go through it before going through lecture 2, which is, so today I'm teaching you about dimension and representation of vector. Possibly, I'll be teaching you by using different teaching style, by using different teaching aids, by using different teaching techniques. At the University of Dar es Salaam and all the universities under TCU, they used to lay in this in the two. They used to lay in every contents or every module. So most of the modules are by using two formality. Number one, having lecture, and then number two, solving the tutorial questions. So I will do similarly because I have to imitate what you are learning in your physical university. So stay connected. So in dimension and presentations of vector, possibly you might find that I will be talking as things that or concepts that you know, but remember that I will be teaching this course for regardless of what level of mathematics you do have. I know some of the contents, possibly you cover them in ordinary at all level because vector, for instance, is one of the topic in Form 4. And also you cover during your ordinary diploma or during your advanced, because I know also vector is one of the topic in advanced mathematics. Advanced mathematics in Form 6. Advanced mathematics of the Form 6. So at the beginning, because I have to build the foundation and reminding you what possibly I've forgotten some months ago, in order for me to build a strong foundation, the walls and the roof on the strong foundation. Okay? So don't get tired, don't be disappointed when I'll be mentioning some of the concepts that you are familiar with. Just be patient. I will take you into the new world of vector. So these are the title of the lecture 2 is comprising 2 parts, dimension and the representation of vector. So let me begin to teach you first of all about dimension, because this is very important concept for the rest of your life in engineering and scientific mathematics, but also in your engineering from core modules or core courses and the engineering and scientific core courses. Dimension of vector. And also this is called the matrices and base calculus for non-measures. So this is for applicants of mathematics, not for the pure mathematicians. Okay, so dimension of a vector. So the fundamental question that I used to ask myself, right? What is dimension? Okay, when I hear a new term, this is how I learn. What is dimension of a vector? What does it mean when you say about dimension? You have this term. So when you mention the term dimension, you can pause the video and try to answer it. Okay, in mathematics, we are using numbers and letters to inform us and different equations and so forth. But sometimes these descriptions is very important so that to have a good mindset in your mind. What is dimension of a vector? So when we say about dimension, we mean about the components of the vector. Okay, the components of the vector. So I found some definition, okay, from different mathematics books. One of the definition is the number of axes. So dimension, we say that is the parameter. So this is the parameter, okay. Simply let us say that this the dimension is the number of axes. Okay, the number of axes, the number of axis means that this is from this way, ax. Okay, axis. Okay, so representing the number of axes. So in the number of axes, okay, the number of axes used to represent a vector. So we say dimension is the number of axes that used to represent a vector. Or we say that dimension is the number of axes, okay, that used to represent a vector. That's one of the definition. So he said that in higher or in mathematics, we say that there are two fundamental fundamental dimension of a vector. And these are, we have the first dimension is called the two-dimensional or two-dimensional. And this is notated as 2D. Or in some of the books we used to have R and then square. It doesn't mean that R stands for relation. But those are the notations. So two-dimensional, okay, two-dimensional vector. Dimensional vector. And the second one, we have also three-dimensional. Okay, three-dimensional vector. So this three-dimensional vector is even in some of the software is 3D, okay? Or in some of the books in mathematics you write as R power 3. So these are the two dimensions that we are going to discuss and we are going to use to represent a vector. Okay? So remember what the vector is, the physical quantity which have both magnitude and direction. So if that's the case now, we say that types of dimension that I have already discussed, mentioned them. So let me go straight forward. But let me discuss with you about two-dimensional vector. Okay, two-dimensional vector. So two-dimension vector, which we can notate as 2D, or we can notate as what? 2D, or we can notate as R squared. What is it? Okay, what is it? So after this concept, I will be teaching about how we can represent a vector. So we say that the two-dimension vector is a vector which consists only two components. And these two components can be presented on only two axes. And this axis, basically, and this axis, and this axis are x-axis and the y-axis if we present it geometrically. So these are the two components. Okay? Example of two-dimensional vector, we can present it algebraically. Example, two-dimensional vector can have a vector A, which is 2, 4. So this is x component. So generally that we present it such as, for example, B as x, 1. This is the general representation. So 2 is the x components and 4 is the y component. So this is the x component, y component. So A is 2, 4. And then we have B, this is 3, -4, right? So it means that this is the vector, okay, which has the x components of 2 and the y components of 4, x components of 3 and y components of -4. So this is the example of a two-dimensional vector. Okay? So in case you have any question, don't hesitate to ask in the comment section. But also you can present even a vector by using letters. Suppose this is AB or this is vector C, but these components are A, T, B. So we have so many examples which can define the two-dimensional vector. Do you enjoy learning higher engineering and scientific mathematics with Olenjolaim? Tell me in the comment section and tell me that you enjoyed this content from which university or which college or which university, which college or which institution, and tell me that you are from in which city if you are learn these contents in Tanzania so I can know how this message has spread out in the entire world for the present and future generation. So tell me in the comment sections. I'll be going through the comment sections and see what you have written. So now let us go to the second type. What the second type? The second type is called the three-dimensional. Three-dimension vector. Three-dimension vector. Okay, three-dimension vector. Okay, very important term. This is, we use 3D. And nowadays we have so many powerful software. For example, that if you are learning about civil engineering, we have so many powerful software which can show you the three-dimensional of the house. So you can see the house in three dimensions, not in two dimension. When you are saying about two dimension, it's just you have, for example, this blackboard, it's a 2 dimension. It's only have the vertical components and horizontal components, but this is the upper surface. But this ruler we can define as a three dimension because it has length, right? Length, also it has width. It has width, but it also has thickness. So even this blackboard, if I will take the outer layer, just in the overview from here, okay, in this, or maybe I ignore the thickness. I ignore the thickness and consider only this front view, then this is two dimension. Myself, Sir Olenjolaim or Teacher Olenjolaim, I'm a three dimension. How about you? Because sometimes, you can be learning about this dimension and think that we are learning something new. No, we are learning what God has created for us to be beneficial. Okay, so we have a fundamental questions. What is the three-dimensional vector? So we say the three-dimensional vector, or 3D, is famous with 3D. Okay, 3D vector, right? Vector. We say that is the vector, right? This is the vector which consists, okay, 3 components. Only 3 components, not more than 3 components. Only 3 components, or these components also grammatically call them axes. Example, right? Example of three-dimensional vector. We have a vector A, okay, and then this is 2, 4, 5. So this is x coordinates, y coordinates, z coordinates. So generally, first of all, before I give you, this is B, I'll give you the general notation. Then we can have -2, -4, -6. Okay? Then we can have a vector C. Vector C, even can have also a certain vector that, let's say vector A. This now is equal to 3i plus, I will tell you what the means of this I, I'll remind you, j and then plus k, right? So this is the three-dimensional vector. So generally, so we say that if you have, let's say, vector A, this we have x components, y, z. 10. So you have those 2 types of 40 of dimension. So you do those 2 types of dimension. So in this course, we'll be dealing with 3 dimension. Why? Because in most cases, or in most real life problems that we want to solve as engineers, we find vectors in those problems which are in 3 dimensions. So that's why the dimension is more important than 2-dimensional. And the good news that we have dealt with 2 dimensions, and actually that we apply 3 dimension more than the 2 dimension, right? If you have any question, ask in the comment section below. So now let us come to the part B of this session, which is representation. So representation of what? Representation of vector. So the question we want to answer, how can we represent a vector mathematically? How can you present a vector in engineering? How can you present a vector in science? That's the fundamental question that you have, right? So we say that so the question which you can ask is, how we represent how do we, as mathematicians, as engineers, how do we represent a vector? Okay, and we should have a universal representation of the vector. So somebody in Asia, if I write a vector and maybe publish online, somebody in Asia has to understand what I mean. Even if that he or she doesn't understand my language, but there's a mathematical language. So he said that there are two ways we will be dealing. I know mathematics is a subject dealing with formulas, equations, letters, numbers. We are going to deal with them. I'm still building the foundation. Tell your neighbor that OLENJOLAI is building a strong foundations of vector in your mind so that it has to be there for the rest of your life, whether there's exam or there's no exam, because we have life problems, exams after even graduations, during our times of being at a college or at a university, and even after our graduation. Okay, so there are two ways of representing a vector, right? There are two ways of representing a vector, right? Okay, there are two ways of representing a vector. So these ways are, the first one, we can represent a vector by using what? Okay, by using two-dimensional vector. By using a plane, when we say a plane, it means XY or XYZ plane. By using a plane, or some of the books say that geometrical representation. So geometrical representation, representing a vector geometrical representation. So just in abbreviations like this. And the second technique, by using, so that I can say that by using unity vectors, unity direction vectors, okay, or unity vectors. Or this one, in some of the book, we can present a vector algebraical. Okay, so you have two ways. By using a plane, either XY for the 2-dimension or XYZ for 3-dimension. And we can present a vector by using unity vectors, either I and J or I, J, and K. And this we call it algebraical. For example, these are algebraical representations of 3 vectors, vector A, vector B, vector C. Also, this is algebraical representations of 2 vectors, vector A and vector B. But vector A here is algebraical representations of 40 vectors. So, as a good engineer, you should know how we represent vectors. Of course, we'll be learning or we'll be reading or reviewing research of other methods as engineers, so you have to understand the common language. Again, this course is taught for the first semester of first year for the many colleges, worldwide, or institutions or universities. Again, in case you feel from your heart, this is my offering to God through Tanzanians and international students. That's why I'm not charging any amount of money. If I could charge you, actually, this is very expensive and worth teaching or training, because I'm very exceptional. And God is the one that making me exceptional. However, that I don't know everything about matrices and basic calculus and the small portions, but I'm ready to teach other students or other people what they know. Okay, so in case you want to offer God your free willing thanksgiving through this program, because currently we have a high running cost to make sure that so many lectures of the matrices and basic calculus are in air, so that you can learn them at any place in the world and also at any time. No need for you to go physically at school. You just need the electronic device and the internet. That's all. So you can send your thanksgiving through this telephone number 0759745331, and also you can read the descriptions of the video below. You can read the descriptions of the video below, so you can get too much details concerning about the bank transactions in case you want to do the bank transaction. So now let us go to the first say that representation means let us focus on representation of of two-dimensional vector. As we say that you can represent a two-dimensional vector either geometrically or algebraically. So we say that a two-dimensional vector, right? Two-dimensional vector, or we call it Arab, okay, can be either represented geometrically or algebraically. Okay, or algebraically. So you have those two alternatives, geometrically or algebraically. Okay, so those are the two ways that we can present. So now let us go to 121. We say that the representation. Let me teach you how you can representation of two-dimensional vector or R square in okay, geometrically. Say geometrically. So let us begin from the geometry which you are familiar with. Okay? So we say that the vector is represented in a plane as a set of ordered pair. So we say that it is represented in the plane as a set of orderly pair. Okay, it is represented in the plane as a set of orderly pair, and this means that x, y. So, if that the case, what do we say? If that the case, now we can enjoy the beauty of this stuff, right? We can enjoy the beauty of this stuff, set of ordered pair. So, whereby x represents horizontal axis and y represents the vertical axis. So, x representing horizontal axis and y representing the vertical axis. So, for instance, we can have a two-dimensional vector like this one. Should have a ruler. We need serious students. This is y-axis, and a love of mathematics will never get tired on drawing the xy plane because that's a mathematical language. So this is x-axis, which is horizontal axis. Possible that I drew it badly. We can draw well. So this is x-axis, and this is y-axis, and this is origin. Okay, if you still remember. And then suppose that we can have a vector here, and this vector is indicated like this. So this is all A. So we can have such kind of a vector, or we can just have this the point A, but here we indicate direction, right? So this is the vector, and this is the certain point, possibly that it might be a certain value of x equal to y, right? So what do we say? That we say that this indicates the direction, and later we'll see also how we can find the magnitude of the vector. So you can label, we can have labeled print 1, 2, 3. You can also have equivalent prints, -1, -2, -3. Then you can have against this print 1, 2, 3, 4, right? Then this one is -1, this is -2, this is -3, this is -4, right? So this is the one of the vector. Again, we can have even another two-dimensional vector between the 2 points. Suppose that this is point B and this is point C, right? Point C. Also, you can find the directions is from up to bottom, right? So this, we have a special name for this. We call displacement vector, and this we call the positional vector. So this also is a vector. We represent geometrical. So this is figure 1, okay? Figure 2.21, okay? And this is titled as what? Presentation of what? Of two-dimensional vector, right? Two-dimensional vector, geometrical. Okay, geometrical. Okay, so that is all about the presentations of two-dimensional geometrical. So we'll be presenting, when necessary, the two-dimensional vector in the XY plane. So this we call the XY plane, right? We call the XY plane. Then the second method of presenting a two-dimensional vector is to say that the presentation of what? Presentation of two-dimensional vector, and this is our R square algebraical. Say algebraical. Okay? So we say that we can represent a two-dimensional vector, right? Okay, by using only two directional vectors, two-directional unity vector, unity vector, or two unity vectors. And these two-directional vectors are I and J, not K. I and J. Some of the books we can have something like this. And then what are the values? What are the values of 40 of I? So the value of I, this is 1,0 in XY plane. And then what the value of 40? What the value of J? The value of J, this is 0,1, right? So algebraically, we can present a vector as point on the XY plane. That's A, X, Y. This is first way of representing a vector algebraically. Second, we can present this vector A as, such as, for example, it is OA, means positional vector. This is equal to X, I, components plus Y, and a unity vector J. So what does this mean? This means that we took X, we multiply by 1,0. We took X, we multiply by 1,0 plus Y, we multiply by 0,1. Okay? So example, we say that, for example, if you have vector OA, this is equal to 3I plus 4J. So that is all about that's the representations of two-dimensional vector in algebra. So we have against another responsibility to learn presentation of two-dimensional vector geometrically and algebraically. Stay tuned. Okay. So, I've been teaching you about the representation of the two-dimensional vector or two-space vector, right? Right now, I would like to take you into the third part of this session, where that I'm going to teach you how do we represent as engineers or as mathematicians, how do we represent as scientists, how do we represent the three-dimensional vector. So that's the next part. Okay, so in case you find that I'm teaching you quickly, you can review this video several times as well as you can. You have to make sure that you remember to subscribe, because we add a video every day in our YouTube channel. So please make sure that you subscribe on our YouTube channel so that you'll get notifications once we upload a new video. Okay? And I'm sorry that my voice is not okay, but don't worry, everything gonna be all right. Okay, so then now we are going for 1.3, and then I want to teach you, my beloved students, about representation. I'm building the foundations of vector algebra for the modules or for the course called Matrices and Basic Calculus. So representation, this is T, presentation of a three-dimensional vector, or in some of the books, 3D vector. 3D vector, right? So you say that a three-dimensional vector or R cubic or space vector, this is also known as space vector because one of the axes is in space, okay, can be represented in two ways. The first way is geometrically. So when you say geometrically, on the three axes, which is x, y, and z axis. And the second way is algebraical. And algebraical will mean that we can use standard unity vectors, or we can use a vector as a point or as a standard unity vectors. So let us go in detail because this is very interesting. Because we have been dealing with two-dimensional vector during our ordinary secondary education. I have the good news also. I'm also training ordinary secondary education from 1 to Form 4 for the 3 subjects. So 3 times 4 makes 12. So I'm teaching 12 subjects for the Form 1 to Form 4 by using the syllabus of United Republic of Tanzania for ordinary secondary education from 1 to Form 4, right? So I have another YouTube channels and another schools that's called the Tanzania Online O-Level Circuit School in square bracket OLENJOLAI. Okay, so make sure that you go through it in case that you forgot some of the materials of O-Level and A-Level. Again, another point that I want to make is means I can go to 1.31 geometrical representation. So representing a geometrical representation of 3D vector. Geometrical representation, or representing a vector in 3, okay, in a plane representation. Geometrical representation of 3D or R cubic vector. Okay, R cubic vector. So we say that a vector, a 3D vector, can be represented on the plane as set of 3 ordinary as a set of 3 points. The 3 points which are x, y, and z. Okay. So you can represent a 3-dimensional vector in 3 axes. Once we know the coordinates of x, coordinates of y, and coordinates of z. So remember that, not before even I draw these 3-dimensional vectors, not before. All the 3 axes of 3D are perpendicular. Say perpendicular. So these are perpendicular to each other. So these are perpendicular to each other. What does it mean? All 3 axes, x, y, and the z axis are perpendicular to each other. So listen carefully because I know that many students, they get confused on the representation. I think, on the representation of this. And so all the 3 axes. So it means that in x-axis x-axis of 3D, three-dimensional, is perpendicular. So let me clarify this one. It's perpendicular to both y and the z axis. This is the revelation. Similarly, we say that the y-axis of three-dimensional three-dimensional plane, let's say plane, is perpendicular, orthogonal, perpendicular to both, okay, x and the z axis, okay, axis. Okay, also z axis, say z axis of three-dimensional is also perpendicular. Remember that we have concepts of perpendicular later on. Perpendicular to both x and the y axis. So, if that's the case now, if you want to draw a three-dimensional plane, plane, okay, plane with three axes, then we have to make sure that all the axes are perpendicular to each other. So listen now, let me share a revelation. So when God was teaching me about actual representation, means that real representations of these three axes. Listen, when I draw a line like this one, this is a straight line. So this is the y-axis. Suppose that is the y-axis. Again, when I draw another horizontal line like this one, so this is the x-axis. So as I say that, the front surface of this blackboard is two-dimensional. So you agree with me that, so listen carefully. When I draw a line like this one, this is for two-dimensional. I rectify it to have a three-dimensional, and you understand that why do we get so much troubles on drawing three-dimensional sometimes on hands. But we get simplicity when we draw by using computers. Okay? This is two-dimensional. So this is our y-axis, and this is x-axis. So y-axis, positive, this is positive y-axis, and this is negative y-axis. Also, this is negative y-axis, and this is positive x-axis, and this is negative y-axis. So negative y-axis, positive y-axis. This is positive x-axis. This is negative x-axis. So you agree with me that the two axes are perpendicular to each other, whether in first quadrant or second quadrant or third quadrant or fourth quadrant. Now, okay, how do you represent the z-axis? This is z-axis. So it means that the z-axis should be represented in this way, in such a way that here it make right angle with positive y-axis, also to make right angle with negative x-axis, and also to make right angle or perpendicular with positive x-axis, and then it's also perpendicular with negative y-axis. So this is positive z-axis that is perpendicular to the surface of the blackboard. But again, as here we have positive y-axis and negative y-axis, we do have positive x-axis and negative x-axis. How about z-axis, which is the third axis for the three-dimensional? The good news is, even in z-axis, we have both positive z-axis and negative z-axis. So this one, it is positive z-axis. And then the negative z-axis is inside the blackboard, right? So if I can drill a hole or a pit, and then this ruler will pass into the other sides of this wall, then we have another negative z-axis, which also is perpendicular to all other axes. So, can we draw? So now let me give you a challenge as an engineer. Can you draw a line here in space? That's why we call this three-dimensional. That's why it is called displacement vector, because one of the axes is on the space, while two axes are always on the plane. So this is the plane. We'll study about plane vector later on. Very interesting subject. And nowadays advanced students, they miss it, they don't learn it according to the year curriculum. But when I learned it during my advanced education center, it was very interesting about vector, plane equation of the vector, plane vector, and equations of the vector equation of the straight line. Very interesting. Okay, so nowadays they just end on the cross product, then they are done. They come to university. Okay, so then we cannot draw the z-axis in this way, right? And then we cannot draw also another z-axis inside the black hole. So if this is the case now, usually we have to align this three axes by using the positive axis, and we align them in such a way that we can be convinced as mathematicians or engineers that those three axes are perpendicular to each other. How do we draw it? Or how do we sketch it? So listen carefully. So we sketch them in this system. This is just for the matter because we want to sketch a three-dimensional plane on the two-dimensional. So this is the way that we sketch it on the two-dimensional. Okay? And if you sketch in this way, okay, the naming also is alternating. So this is another axis. And then this is another axis. Possibly that maybe I didn't balance, should maybe adjust it a little bit, but that's the way we represent. You can adjust this to here, this line, and that line, I think that let me do that. At least they can make it will be a little bit logical to you. Okay? So that we say that here we have another line. It's a little bit challenging to draw as a three-dimensional on the two-dimensional. But for example, in our class notes, you'll see exactly a three-dimensional figure because they have used a computer to draw that three-dimensional figure. So this is a three-dimensional plane, 3D plane, or we call it displacement vector. So fundamentally, we can sketch this axis as y-axis. However, that this axis can represent either y or z or x-axis. And then let us call this one as x-axis. And then let's call this one as z-axis. But you can use these names interchangeably. And here we just consider the positive. This is on a positive y-axis. And this is negative z-axis, positive z-axis. And this is positive x-axis. So in case you need negative, then it means you prolong these lines. This is the negative z-axis, negative y-axis, negative x-axis. But the challenge is the plane. Okay. So if this is the case, so this now it is what this is we call this. So suppose that this is figure. So this is figure 2.22. Okay, and then this is figure 2.3, and this we call it 3D plane vector. Okay, 3D plane. So it shows 3D plane. So it means that now we can have a sketch of a print. We can have some prints there. So for instance, that we need to sketch a vector because that's our aim. So you have a certain vector which has three components. Suppose that here we have certain point, a certain vector P. So then we say that we can draw a line and show the direction. So this is the origin of the vector, and this is an arrow to show the direction of the vector. And this B has component x, y, z. Also, we can have possibly another vector. Okay, can call it, let's say, vector A. So this is vector A, and also it is x1, y1, z1. Okay, so also this is the directions of the vector OA. Okay, so soon in the next lecture I'll teach about position of vector. So this we call it vector OA, and this we call it vector OB. But also you can have another vector which is three-dimensional at this point. Let's say that this is vector C, like this one. But again, we can have another vector, which is now a space vector, not a positional vector. Then this is from point B to point E, and this is the direction. So all of these are vectors on the three-dimensional vectors. So that's how we represent three-dimensional vectors or geometrically. It's a little bit challenge, but you have to be familiar on these programs, right? Okay. So then we say that the second way of representing a 3D or three-dimensional vector, we say that 1.2, we say that algebraically, okay, representing presentation of a three-dimensional or R cubic or space vector algebraically. Okay? So the representation of the 3D vector or space vector algebraically. So you can represent a three-dimensional vector. So I say that algebraically. So we can represent a three-dimensional vector, okay, algebraically, by using coordinates, by using either one by using coordinates. Okay, coordinates mean that here is x coordinates, y coordinates, and z coordinates. And also we can use standard unity vectors. So standard unity vectors. These are I, J, and K. Okay, so you have those two ways. So by using examples, for example, so we say that example of Roman 1, we say that we have vector A, right? And this vector A represents as 3, 4, 5, right? And then you can have vector B, algebraically as a point, represents as -3, -4, 0, right? Also, we can represent it by using standard unity vectors. Say standard unity vectors. Standard unity vectors. Standard unity vectors. These standard unity vectors are I, J, K. Okay? I, J, K. Standard unity vectors. So by using these standard unity vectors, first of all, you have to know in your mind the value of I. This is equal to 1, 0, 0, right? Again, the value of standard vector J, whether J is reference lines, this is 0, 1, 0. Then we say the standard of K. Standard of K, this is equal to 0, 0, 1. So those are the three components for standard vectors. So then, for instance, that you want to present vector A, which initially it was 3, 4, 5. The arrangement is x coordinates, y coordinates, z axis, or z coordinates. So this one can represent it as 3 times I plus 4 times j plus 5 times k. So simply we say that possibly vector OA, if it's positional vector, because in this sense it's positional vector, this is equal to 3i plus 4j plus 5k. Whether this way or in some of the books, we use bold as ij, you can use the wave lines. That's all. Then for point B, which represented as negative 3, negative 4, 0, this also we can multiply it. So this is equal to negative 3, negative 4 with just the dot I, j, k. So later on we find that we just dot. So if we dot, we get positional vector OB. Dot, you don't know, possibly forgot what it means of dotting, but we will teach it. It's the contents, it's one of the components. So negative 3i minus 4j plus 0k. Then this is OB. So OB, we say that this is negative 3i minus 4j plus 0k. Okay? Okay, so then this is the case that you should have. OB, that's vector B, and so forth. So standard utility vectors ij and k. Okay, so these are just the representations of those of the three-dimensional vectors. So you can go further as well as you can to enjoy the beauty of vector or vector algebra. So I'm about to end this lecture 2, and let me leave the homework because I should not leave you without homework. Say it's a homework time, tell your neighbor it's homework time. This is homework 2. Every lecture will have its homework. So homework 2. This is homework 2. Homework 2 is state that this will be example 1 also. Example 1, if you've understood what I've been teaching you, then do this example 1. Locate vector Q, which is 2, 4, 5. Then here we have vector R, which is negative 2, negative 3, 4. Then we have S, RS, OPQ, RS, which is negative 2, 4, 3. Okay. And also we have the first point. Try this work. And point Q, which is 2, 4. Point Q, point P, point P. This point P, it is 2, negative 3, 4. In three-dimensional plane. In three-dimensional plane, or in 3D. So do that homework. After you do it, submit in the comment section, share with your colleagues, share with your classmates, and then enjoy the beauty of vector algebra as the first topic of the course called Matrices and Basic Calculus. So this is the end of lecture 2. I really thank God because He's the one who gave me this idea. He the one who revealed the actual and physical problem. He the one who developed in my mind the solution on how I can solve that problem. Even I can minimize if I can't solve it completely. And I thank because he has been with me every time once I want to get prepared to teach these contents and teach mathematics or physics or science, because I'm also teaching. I've also other 5 official YouTube channels. You can see the links that at the end of this video. And then I thank God because he helped me to teach you effectively physically when I've been teaching you at this place. I really thank God also who have given you an opportunity to stay back of your smartphones, back of your iPhone, back of your tablet, back of your iPad, back of your computer, back of your TV, back of your desktop, back of your laptop. So back of your any receiving electronic device, and you join me from the beginnings of lecture 2 to the end of this lecture. I would like also to invite in lecture 3, because we'll have so many lectures, because I want to explain every concept is in simple language, so that no need of too much hassling that many students used to experience, because that is my responsibility to simplify, but also I need active students, because in every lecture I will try my level best to leave their homework, and you have to make sure to do their homework before you go for the next lecture. Keep on inviting our friends, inform them, tell me in the comment section you are enjoying this content from which college, from which institution, from which university. And the real that I tell you that in advance that stay enjoying the beauty of engineering, mathematics, and scientific mathematics. Possibly you might find that maybe I'm so talkative, but that's the characteristics of a talented teacher, because you know my mouth is kind of the one of the office, and the brain also is just delivering the contents. But again, you might see that what you cover in lecture 2, you know it in advance. That happens sometimes because I'm teaching according to the curriculum of University of Dar es Salaam. So remember that these are the contents. I can't teach you something which is not there, because it won't be useful for the rest of your life. And I know possibly you know even this contents more than I do know. Remember that OLENJOLAI does not know everything, but I know small portions of what called the vector algebra, and I'm ready to teach present and future students about what I know. So may God bless you. I'm always praying for all my online students. Share these contents with your classmates, with your colleagues. Speak, communicate, give me feedbacks on the comment sections, whether you understand, or in case that you have any questions, because I want to interact with my students. Use the comment sections below there to ask your questions. Read also the descriptions for you to get too much details concerning about the video you are watching right now. Make sure to visit our channel that's called the Online Undergraduate Polyinstit of Tanzania, _OLENJOLAI M. So may God bless you until we meet inside lecture 3 of matrices and the basic calculus. See you then.